Hello, everybody. Today we have multiplying decimals. Here we have, it says decimals can be multiplied, but they follow different rules than adding and subtracting. So we're going to practice multiplying the following whole numbers, and I'm going to focus on the middle problem right here, and I'm going to ask you to do the first and the third problem. So on this first problem right here, we have 208 times 14. So I'm going to go ahead and just start my process, and I have 4 times 8, which is 32. But now don't forget, I can't write 32 in that line, right? Because we can only use numbers lower than 10. So what do I do with my 3, my 32, my 3 and 32? I'm going to put it up here above 0. Now when I'm done multiplying, I can add that number in. So for example, 4 times 0 is 0, plus 3 is 3. Okay? And then I have 4 times 2, which is 8. And I just want to point this out as well. I said 4 times 2, but what I really am doing is I'm multiplying 4 times 200, because this 2 is in the hundreds place, which is why you would get something like 800. Okay? So when you're going to move down, I could say 1 times 8 here, but really what I'm saying is that this is 10 times 8. Why? Because this 1 is in the tens place. So what I am going to do is I'm going to hold the place value, because I'm using a 10. So I'm going to hold the place value with a 0, since I'm working with a tens place. If I was working with a hundreds place here, I would need to leave 2 zeros. But I don't have a 3-digit number down here, so that's okay. So I'm going to go ahead and I'm going to hold my place, put my place value 0 holder right there. Now I can begin. So I have 1 times 8, or really it's 10 times 8. So I'm going to write, basically I'm writing 80. So this kind of just proves my point. Now I have 1 times 0, and one of the things about math is you want to use a pencil so you can erase. You don't want to leave the numbers up here. You want to erase them so you don't get confused. So I have 1 times 0, which is 0, of course. And then I'm going to say 1 times 2 is 2. But really another way to say that could be 10 times 200 is 2,000. I know this says 2,080, but I'm just telling you 10 times 2 is 2,000. Now, once you're done, you have to add up these numbers. All right, so I have 2 plus 0, so I have 2. And then I have 3 plus 8, which is 11. So I'm going to need to carry the 1 over from it. Okay. So because it was 11, I'm going to carry my 1 over to the other part right here, plus 1 there. So now I have 1 plus 8, which is 9. and then I have 2. There's nothing with that 2, so it's still 2. All right, so there's an example from this part right here. Now, it says describe the process you took to multiply the numbers. You could basically say anything here. You could say I used a place value holder of 0 when I multiplied in the tens place. I multiplied numbers. I mean, really, that was your process, you know? So I'm going to move on down then. Right here we have multiplying decimals, and we have a little notes on that. So it says multiply the digits as usual, ignoring, meaning you're going to pretend like the decimal point is not there. So number 2 here, it says the product will have the same number of digits behind the decimal as the multiplicand and the multiplier combined. And that sounds complicated. I'm going to try to make it simple for you. In number 2, basically, your answer has the same amount of decimal places as your problem. So let me give you a problem right here. So in number 1, we have 46 and 7/10 and 16. Well, I only have one number that's in a decimal spot. So that means my answer is only going to have one decimal, right? And just to prove that real quick, oh no, there we go. To prove that real quick, let's see. My answer should have one decimal place. So, hey Siri, hey Alexa, what is 46.7 times 16?
46.7 times 16 is 747.2.
747.2. And as you can see, I have one decimal place in that 0.2. So really all you got to do is count your decimal places. And I'm going to do number 2 for you as well. So really what I want to know is how many digits will be behind the decimal in the solution, really your answer. So how many decimal places are there? There are 4 right here. 1, 2, 3, 4. Anything after the decimal point is considered is what we're considering when we're placing our decimal in our solution or our answer. So I have 4 decimal places here, which means my solution will have 4 numbers to the right of the decimal. So I have 4 decimal places, and just again to prove my point, hey Alexa, what is 1.58 times 0.23?
1.58 times 0.23 is 0.3634.
There we go. I have 4 decimal places. All right, so you can go ahead now and do 3 and 4 on your own. It says we can use estimation to check for reasonableness. So what they're doing here in number 5 is they are rounding 1.9 to 2. So a real quick example, 1.9, right? I can do 6 times 9, which is 54. And I'm going to need to carry the 50 over to the tens place. It's not really plus 5, right? Or I'm going to carry that extra. I regrouped in my tens place to make a 1, sorry. So now I have 6 times 1 is 6 plus 5, which is 11. All right. So now I've completed the problem. How many decimal places are there? Well, there is only one decimal place, and it's this 9 right here. So because there's only one of these, that means I only have one decimal point. So I'm going to go ahead, I'm going to try to draw one right here. I can move it. There we go. Oh, that's a little big. Try it again. Whatever. So my decimal point will go right there. There we go. One decimal place, one decimal. Now here's their point. Is 11.4 can be estimated, and it's reasonable to say that 1.9 times 6 is going to be very close to 12. Okay? So what I'll do is I'm going to fill in what we can round these to in order to get my answer. So 94 hundredths is very close to the number 1. And you can multiply the number 1 by 5. And on the next problem, 5.7 is very reasonable to say that it's close to 6. And you can multiply that by the 11 that's there. Again, if I'm going too slow here, you can always change the speed of your Loom video, just saying. Alright, so you guys are going to need to complete these problems right here. Alright, I'm going down to the bottom. So it says use your understanding of decimal multiplication to solve the problems below. So they want you to rewrite the problems in a box like this. Alright, just because it lines everything up. But notice they didn't use a decimal, which is totally cool. Alright, because all we got to do is count the number of decimal places, and our answer is going to have the same amount. So in this problem, I'm definitely only going to have one decimal in my solution. Okay, so I have 3 times 8, which is 24. I'm going to carry the 2 over the tens place because it was a 20. And I'm going to be adding it to the existing 60 that's there. I know it says 6, but really that's 60. So then I have 3 times 6, which is 18 plus 2, so that is 20. So right here it says I have 204, but really I need to add my decimal place in, right? So you can go ahead and add your decimal place in where it would be. Or you could just rewrite your answer underneath the problem. Either one is fine with me. Alright, going on real quick. Okay, so I have 7 times 5, which is 35. I'm going to need to carry that 3 over, right? Now I have 7 times 1 is 7, plus 3 is 10. Now I think they tried to confuse you here, because if I were going to multiply the 0, I would hold its place, but 0 times 5 is 0, and 0 times 1 is 0, so the whole value is 0, so I don't have to worry about anything. And this problem only has one decimal place, so that means my answer, my solution, will also only have one decimal place. And you could do that right there, or you can rewrite the answer underneath the problem. Alright, let's look at the bottom real quick. Number 17 says, Amber has a dog walking business. She walks a golden retriever 1.8 miles each work day for a week. How many miles does Amber walk the golden retriever? One little note, a work day is Monday through Friday, so she's only walking this dog 5 days of the week. So we have 1.8 miles multiplied by 5, the total amount of days that she's walking, and you'll get your answer right there. Number 18, it says Fiji apples are priced at $1.79 per pound. If Hayden purchases 2.5 pounds of apples, what will the total price of his purchase be? Alright, so I did set up the problem for you, and you can go ahead and find the solution to number 18. And when you are going to summarize today's lesson, it is always helpful to take any of the information from above here, any of these steps right here, okay, or you can mention anything on the top of the page, but as well, anything I've said in this video, you could write down here as well. Alright, that is going to be it for the day. I want everyone to have a great day and stay safe.